Hi, in this video I'm going to solve another question from IIT JAM Biotechnology 2013, and this question basically asks that what would be the correct Fisher projection corresponding to this structure. So they have given a structure in wedge form. You can see they have given a structure in the wedge form, and now they ask what would be the appropriate structure, which structure actually matches the given structure in the question. So how to proceed in this question? So best way is to write the RS forms, RS nomenclature, basically RS forms for each compounds. So first our analysis would be on this compound. So we would write the RS nomenclature, and here is an easy trick how to write the RS nomenclature very easily and in a time efficient manner. So first we have to identify the stereocenters. Here are two stereocenters, means two chiral carbons. So now first we have to label the groups attached to this chiral carbon. So if we take this chiral carbon, so first we would label this one. This is the top priority group, so we would label it as 1 because oxygen has the higher molecular weight, so it would be 1. Then we would label what? We would label this whole group. This would be of our second priority. Then we would label third, the methyl group. Now the rotation would be like 1 to 2, then to 3, and this rotation is clockwise, so it implies it's a R configuration. If we do similarly for the second chiral carbon, bromine would be of top priority because it has higher molecular weight. It has the highest molecular weight actually. Then what will happen after bromine? uh, Second priority would be this large group, and then third would be this CH3, then 1 to 2 and 2 to 3. The rotation is here clockwise. Again it would be a R configuration. Okay, here we don't have to bother about the hydrogen because both of the hydrogens are projected uh, back of the plane of the paper, so we can easily see the rotation direction and we can write whether it's a R configuration or whether it's a S configuration. So for Fisher projection, what is the rule for judging whether it's a R or S? So the rule is, if the hydrogen is in the side position, then we have to do some rotations, but it's very easy. Let's say, so if we take this chiral carbon, this would be our top priority group because oxygen has a higher molecular weight. Then this carbon would be the second chiral carbon would be the second priority group, and the third priority group would be the CH3. So our rotation would go 1 to 2, then 2 to 3. So this rotation is actually looks like the rotation is actually anti-clockwise. So you might be thinking it would be a S configuration, but no. Look at the hydrogen is here in this side. This means the hydrogen is projected upward from the plane of the paper. It's not projected behind the plane. So that is why if we have to give one conversion, then we would write it R. So it looks like S, but we would write R. So here is the trick. It would look like S, but if the hydrogen is here, we would just write the opposite configuration. So let's try again with another chiral center. For this chiral center, bromine would be top priority. Then second priority would be this whole group, and third would be this CH3. So our rotation would go like 1 to 2, then 2 to 3. So it is anti-clockwise rotation. So you would be thinking anti-clockwise rotation, so it is no, hydrogen is in this position, so it looks like S, but it would be R actually. So this is the trick. By applying this trick, you can easily see whether the nomenclature is R or S. So it's very easy technique. So here we write RR for both stereocenter, and from the above wedge structure we also get that there we have RR. So this option is probably the correct option, but still we have to, for safety, we have to look other options also. So let's check option B. Top priority would be O, then it would be the second priority group, and this would be 3. So it would rotate like this in a clockwise fashion. It looks like R, but it would be S as the hydrogen is here. If hydrogen is like horizontal in this condition, we have to change its configuration. It looks like S, but it looks like R, but actually it would be S. So let's analyze the second stereo center. Bromine would be top priority, then it would be like second priority, and the third priority would be CH3. So our rotation would be 1, 2, then 3. It looks like R, but actually it would be S. It is clockwise. It looks like R because but it would look like S because hydrogen is here. So here we get a SS configuration. So this would not be correct option. Let's analyze option C. Option C, here it is OH, it's 1, this would be 2, and this would be 3. So the rotation would be 1 to 2 to 3. It is anti-clockwise. It would look like S, but it would be actually R as the hydrogen is over here. Now going to the second stereo center, bromine is 1, this would be second priority, and this would be 3. So 1, then 2, 2 to 3. This is the clockwise rotation. So it would look like R, but it is actually S. So here the configuration is RS. It doesn't match with the question, the particular structure given in the wedge form. So it won't be the option. Okay, again in the same formula, let's please analyze this last structure. So for first, this would be top priority group because it has oxygen bound to it. Then this carbon along with all this group would be the second priority. This would be the third priority. Rotation would go like 1 to 2, 2 to 3. This is the rotation direction. It is clockwise. This is the clockwise rotation direction, but it would be actually S because hydrogen is over here. So as it is S, whether the second carbon is R or S doesn't matter. This option is incorrect. So we need both R. Hope you like this video. Please like and subscribe.